now we will see what is greenhouse effect. So, when earth absorbs energy from sun, then it re-radiates back into space. According to steady state, whatever solar energy it accepts, it must radiate that energy. So, in greenhouse effect what happens? Atmosphere plays a role. What atmosphere does? It also absorbs the emitted radiation from the earth, and then some of this energy is re-radiated back to the earth and some to the outer space, and in this way the earth is kept warm. So, this warming of earth because of the role of atmosphere will be actually called greenhouse effect. Let us see with the help of Stephen Boltzmann law how the atmosphere helps in increasing the temperature of earth, that is warming. So, if atmosphere is not there, then what will be the average temperature of earth? In the presence of atmosphere, that is the greenhouse effect, what will be the temperature of earth? That is called greenhouse warming. So, this is our earth and there is no atmosphere, let us suppose, and it receives energy from the sun. So, let the solar constant be S. So, we will assume certain things. Let the solar constant i.e. the amount of energy falling per unit area on the surface of earth, per unit area normal on the surface of earth be denoted by S. This is solar constant. So, earth will absorb the solar radiation. Whatever the radiation falls on earth does not, this is the radiation falling on earth, of which only some percent the earth may be absorbing. Suppose it absorbs, so let the solar constant in the amount of energy falling per unit area. Let F denote the fraction of this energy being absorbed by earth. So, what happens? All of this energy is not absorbed, some energy is reflected. So, how much energy is reflected? Will be some absorbed, the F fraction of the energy incident on it. Now, there are two things. The earth absorbs this incoming radiation and then it radiates in space the energy which is the characteristic of its temperature level. So, suppose Te is the temperature of earth. So, it absorbs energy from only this cross sectional area, but it radiates energy from all directions. So, at steady state the energy absorbed by earth is equal to energy radiated by earth. So, how much energy is absorbed by? So, solar constant S, only F fraction of it is absorbed. So, S into F is the energy absorbed, and how much, this is the per unit area. So, how much area is of the earth is absorbing solar radiation is given by pi radius of earth whole square. So, only you see this cross sectional area of earth is absorbing this influx. So, pi Re square. Now, how much energy is radiated? So, this is sigma 4 pi radius of earth whole square into temperature of earth to the power 4. So, this pi, radius, this radius of earth cancels, implies surface temperature of earth is S solar constant into the fraction it absorbs by sigma, and this is 4th power. So, we have the temperature of earth, we got it is S F by sigma, and this is equal to 4th power of this. So, this is in the absence of earth, this is the surface temperature of earth. Now, let us see the role of atmosphere. Now, let us see the role of atmosphere. So, you see this is we have earth and this is earth and its radius is RE. Now, we assume that, let us exaggerate a diagram. This earth is surrounded by a atmosphere. Generally, that the portion of earth which causes this effect is very close to the earth's surface. So, this is a spherical shell, I am shading it, of the atmosphere. Generally, the clouds, the region 20-30 kilometer of inner atmosphere region above the surface of earth has this role. So, what it does? This is transparent to actually solar radiation. So, this atmosphere is transparent to the solar radiation from here, because most of the radiation is in the ultraviolet, visible and all those things which may be absorbed by the surface of earth, water and all this land. So, plants they absorb these incoming radiations. So, this is transparent to this radiation. Now, what happens? The earth absorbs the incoming radiation and it as the characteristic of its own temperature, it also radiates energy. So, it emits radiation in all directions characteristic of its temperature. Now, this atmosphere again, you see what it does, it again radiates this energy, it absorbs this energy and then radiates back into deep space and back inside the earth, because it is again black, means it has again two surface, it emits back to space and it emits in infrared region. So, it emits, what happens? The earth emits is in infrared. Now, the earth is absorbing visible part, ultraviolet part, infrared part absorbing, but it is emitting characteristic of its temperature which is in infrared. Now, this one absorbs infrared. So, these clouds or this atmosphere, lower atmosphere absorbs it infrared and then re-radiates back to earth and then it radiates back to atmosphere. Let its temperature be TA, atmospheric. So, let us first see that when we enclose earth with an atmosphere, its effect has to be taken, then what is the temperature of the atmosphere? So, you see here, let us consider the heat equilibrium of atmosphere. That means how much heat it takes, how much it radiates. So, this distance is negligible, this is 20-30 kilometer compared to 6,400 kilometer. So, energy absorbed, energy given by earth, this is, or let us call it at steady state, energy absorbed by earth, from earth by atmosphere is equal to energy radiated. So, energy absorbed is energy radiated. From where it is absorbing energy? The emitted energy of earth is altogether radiated. Sigma T pi radius of earth whole square, temperature of earth to the power 4. This is the amount of energy earth is radiating and all is absorbed by the, I assume that this atmosphere is behaving like a black body. Now, the energy this atmosphere will radiate is inward and outside. So, 8 pi radius of earth nearly radius of earth T atmosphere to the power 4. 8 because this is inside and outside. So, 4 pi r square inside, 4 pi r square outside, pi re sigma implies atmospheric temperature is Te by T by 2. So, Ta is equal to Te by 4th root of 2. This is one point. Let us call it equation 1. So, we got atmospheric pressure temperature as T by 4th root of 2. Now, so now I could relate the atmospheric temperature with the temperature of the earth's surface. Now, let us see again that previously we have seen the temperature of earth in the absence of atmosphere was 4th root of this solar constant F in the fraction by sigma. So, this was the temperature of earth. Now, let us see that if I take the role of atmosphere, then what will be the temperature of earth. So, I have to write down the new heat balance equation. Now, let us write. So, new heat balance equation for earth. That means greenhouse effect is taken into account, that is the greenhouse effect or the role of atmosphere is taken into account. So, you see here, this is our atmosphere and this is a shell, atmospheric shell. Now, this is earth, this is our exaggerated diagram, this is earth. So, you can see this earth receives energy from the sun. The solar energy is shown by this curly arrows. Then this has a temperature, new temperature Te, this has a Ta temperature, it emits radiation in all directions and you can see by this block vectors arrows I have shown the energy radiated by the atmosphere. So, at steady state the heat balance equation is written at steady state. So, at steady state energy absorbed per unit time is equal to energy radiated per unit time. So, let us see energy absorbed, what is the quantities, who are absorbing energy. So, solar energy absorbed by earth plus energy emitted by atmosphere which is absorbed by earth is equal to energy radiated by earth. So, let us start with this one, the solar energy absorbed by earth. S is a solar constant, F is the fraction which is absorbed, and the cross section which is absorbing this solar radiation is only pi radius of earth whole square, plus energy emitted by atmosphere. You see, atmosphere has this area and this area. So, we have denoted the area of suppose I denote the radius of earth Re. So, this is also Re. So, we have sigma 4 pi radius of earth whole square. This is the area of the atmosphere which is radiating energy inside, and that is T atmosphere to the power 4. And what energy we are radiating is sigma 4 pi radius of earth whole square T e to the power 4. So, Re square and pi Re square, pi Re square, pi Re square. So, we have S into F plus this is 4 sigma Ta. We have already derived in previous relation that Ta is equal to T by 4th root of 2. So, Ta is again T to the power 4th by 4th root of 2, that is 4 sigma T to the power 4. Now, S into F is equal to 4 sigma 1 minus 1 by 4th root of 2 T to the power 4, implies T is equal to SF by 4 sigma 1 minus 1 by 4th root of 2 to the power 4th root. This is the Te, the new temperature of the earth. Recall, in the absence of atmosphere, Te was equal to 4th root of SF by sigma. So, SF by sigma. Now, this quantity is greater than this quantity. So, thus the temperature of earth is increased by this factor. So, thus the role of atmosphere is to give this back some energy, and this way you can see the earth is kept warm due to greenhouse effect. This is greenhouse effect.